And we're live. All right, so geometry quiz number 3. Can you believe we've only had 3 quizzes? And by 3, I mean we've only had 2. This is our 3rd one?
You actually can say that today.
Nope, not going to. Boo! No, sit down, Danny. No one cares. So it's the review for quiz number 3. We've had 2 quizzes, 1 test. Plenty of time to make them up. We've had way more than 3 weeks of school for 3 tests, or 3 quizzes, I should suppose, 3 exams. Here we are. If you open your hymnals to the last page. Yep. Guys, I know the review packet looks intimidating. She's thick, but she doesn't have a lot of problems, right? It's what we want. Only 11 problems. It can be. The last one, I'm sure you're going to want to see, because if I were a betting man, and I am, in fact, I bet on the St. Louis Blues to win the Stanley Cup. I don't know if you know that. Back in December when they were the last place team in the league. And they won! My only regret is I didn't put more money down. I didn't have more money to put down. I just put down a little bit, and I was like, you know what? What the heck? The odds are so crazy. They'll never win. They're the Cubs of the NHL. And then they did, right? And I got a decent amount of money, but not nearly as much as some other people that were smarter than me, or had more money, I guess, right? It's easy to make money if you have money. Some guy won like $6 million. Like, yeah. Like, right? Just my luck, right? Just my luck. I mean, I guess I got lucky enough to get it right, but of course. I also bet on Boston. I don't know if he told you this. At the same time, like back in December. I was like, people are underrating them. So 2 teams I betted on actually ended up in the finals together. So I was guaranteed to win either way. One I put a lot of money on. Well, decent amount. Put it on the Blackhawks? No way, they suck. They're not going to be good enough.
They should have put your house on. But that's probably what you said about the Blues.
Yeah, no, actually the Blues, I had been predicting for the last 3 years that was going to be the year we won.
A lot of money.
Just everything was going to come together. And then we got Ryan O'Reilly. Ryan O'Reilly! The man, the myth, the legend. You don't probably know much about hockey, but that guy, okay? Buffalo was like, oh yeah, he's like terrible in the locker room. He doesn't love hockey. He's this awful guy. He comes in, get on my back. I'm taking you to the promised land. Right? What a god. That guy. That guy. What a story, too. What a story.
Remember the guy that scored the game
Ryan O'Reilly. Man. What a god. Next jersey guaranteed. Actually, that's not true. I have to get a Pavel Demitra jersey first in memory of Pavel Demitra. Been saying that for years.
Patrick Kane jersey.
Yep, he's scum. You know what's nice about the Blues is that everybody on that team isn't a giant jerk. Right? Like Patrick Kane. Like, God bless you for winning 3 cups. But at least our players aren't all jerks. All right. Wayne was a St. Louis Blue. A great one. Played for the Blues. In fact, almost every great player that ever existed has played for the Blues. They were just like past their prime when they did. Jacques Plante, one of the best goalies of all time, the guy who invented the actual goalie mask. Anyway, A, B, and C are collinear, D, B, and F are collinear. Are we all here now? Wonderful. So given that A, B, C collinear, and this should feel familiar from yesterday, or 2 days ago, and D, B, F collinear, that's what we're given. Now, what does it mean to be collinear? On the same line. So if the points are on the same line, they must be on a line, right? So we can conclude that DBF and ABC are lines. So that's going to be our first thing that we're going to write down. Let's do that. So therefore, we know that ABC, the figure, it's a line, and DBF. Now, I could leave it like that because those symbols mean they're lines, but you guys would get confused, I would assume. Like, Xavier's going to, like, come back in just, like, a second. He's going to be like, wait, what? What does that mean? And so I'm going to write it out for him. That way he knows. Are lines. Gotcha? All right. So we know those are lines. And how do we know that? By definition, right? If the points that are on the figure are collinear, then that figure must be a line. Did we define that officially? No. But, again, you don't need to know all your definitions. That's not what this is about. Okay? This is not vocab, the class, okay? This is geometry. If you know it when you see it, it's good enough. It's definition. All right, so before we get going, Autumn, give me a color for angle 1. Green. All right, so angle 1 is going to be green. Wherever I see an angle 1, I'm going to make that green. I would encourage you to get some of these pens. Shout out to Pilot. Please sponsor me. Pilot G2 is the pen. 07 is the thickness, so it's a little bit thicker than the 05s, extra C, right? Here's the difference. The 07s feel like you're gliding across the page, and they're a little bit thicker. Whereas the 05, if you see this, these you can buy in bulk, like for red, green, and blue and black, the main colors. They feel like you're writing with a knife and cutting the page. So just a little bit thicker, just a little bit, right? 0.02 millimeters, I would assume, difference. you can buy the 07s in a pack of like, I don't know, it gives you every single color for $17. I would encourage you to do that to last you the whole year. Mine only lasts me 3 weeks because you guys suck all the color out of my life. All right, so we've got angle 1 is green. Let's do that. What color would you like angle 2 to be? Yes. Purple it is.
This necklace exists.
Erica, what color would you like angle 4 to be?
Blue.
Blue. All right, we have options.
The white one.
The light one? Okay. Everybody seems to like the light one. All right, and we have one more angle to do, angle 3. Alex, what color do you want it to be? Wait, what? Cheyenne says pink. Alex, do you agree with pink? Alex is not even paying attention. All right, so here we go. Angle 3, wonderful. That was a nice curve. That was a nice curve. In fact, the purple one's nice too, and all those are really nice except the green one. All right, so here's what we're gonna do. We're not allowed to use vertical angles theorem. What we're trying to prove is that 1 and 2 are supplementary. Okay? It's the same thing we did yesterday. It's just different order. Notice when we did it yesterday, we got that for free early on. I'm not gonna pull it up. What? You what?
Blow it up.
All right. Yep, no problem. So we need to prove 1 and 2 are supplementary. Well, we're not allowed to use vertical angles theorem. What we're going to do is we're going to say, look, 1 and 2 are on a line. We just established that. So what do we know about those two angles? They are they equal 180. You're right, but how do we know that? You're jumping the gun here. Yeah. They're a linear pair. And if they're a linear pair, then we can use linear pair theorem, right? Which says if they're a linear pair, they are, right? Then they must be supplementary. And then if they're supplementary, we win. That's it. That's it. That's it for the first half. Okay? Remember we got that for free. I went back the other day and boxed it and was like, hey, by the way, we did that earlier, right? I just put it first now. Make it easier on you. All right, so let's do that. So these are lines, which means angle 1 and angle 2 must be a linear pair by definition. So I'm going to write that. Angle 1 was green. We did that with an 07. So 1 and angle 2, where's my light purple? There we go. And angle 2 are a linear pair. We know that by definition. Right? If they're on a line, two angles on a line, linear means on a line. Oh, thank you very much. Yeah, I'm super zoomed now. I'm zooming back out on them. Deal with it. All right. Here they are, okay? They're a linear pair by definition because they're on a line and there's two of them, right? Pair means two, linear means on a line. Now that we know that it's a linear pair, we can use the linear pair theorem. Remember, the only thing linear pair theorem says is they have to be a linear pair. So you have to establish that first. And now you can use linear pair theorem, LPT. And you can say that, therefore, 1 and 2 must be supplementary. We cannot say they're equal to 180 yet. We're not there. Linear pair theorem just says they're supplementary. I know it's pedantic. That's how it is.
What's pedantic mean?
Pedantic means that it's like you're being really technical and like very hoity-toity about it, right? Like Dr. Blackwell would always be, Dr. Blackwell would always be like Dr. Blackwell, not Mr. Blackwell, right? He's being a little pedantic. Now, does he deserve to be? Yeah, he went to school for it and came back to Podunk, Illinois and taught us stupid kids, right? But he was being pedantic about it.
Versus Mr.
That's not what we're talking about here, Danny, but keep trying. 1 and 2 are supplementary. Therefore, I know the measure of angle 1 summed with the measure of angle 2 is going to get me 180, right? And that's by definition of supplementary. So another by def. And we're done, right? Because that's what they want us to prove. Actually, we went even further than we had to. We could stop right here. 1 and 2 are supplementary. Done. Now, we're going to use that to prove the other stuff. Angle 1 and 4 are congruent, 2 and 3 are congruent. Now, as an aside, it also wants us to prove that 2 and 4 are supplementary. Well, we did 1 and 2. Wouldn't 2 and 4 also be supplementary for the same reasons? Linear pair theorem says they're supplementary. We win, right? So by the same logic, by similar logic, I'm going to draw a little arrow over here. By similar logic, we know that angle 2 and angle 4 are supplementary, which is what they wanted, right? Again, write angle 2 first, because that's what they wanted. And angle 4 are supplementary.
Can't really read that.
Because it's too small?
I don't know. Otherwise, it's just a little sloppy. Similar one.
Yeah, that has to no.
Luckily, I read it out loud for you.
Let's sneak this.
1 and 2 add up to 180. We've proven 2 things are supplementary. Now we got to prove that 1 is 4 and 2 is 3. Okay? So how do we prove 1 is 4 and 2 is 3? Well, if you notice, we've already got 1 and 2 in an equation, right? We need to get 1 and 4 together. So look back at our diagram. Here's 1 and 2. Here's 4. Hard to get 1 and 4 together, right? Can't do that unless we use vertical angles, which we're not allowed to use. So if I got 1 and 2 together, maybe I can get 2 and 4 together, right? Didn't we just do that? They're supplementary, right? So what does that mean? What does it mean for them to be supplementary? Measure of angle 2, what? What does it mean to be supplementary? Come on.
Add up to 180.
Very good. So that little side thing helps us get the thing we need next. Again, by definition. Right?
Everything. Yeah, by definition.
Pretty much, right? So these 2 things, what do they have in common? Well, of course they have angle 2 in common. And you could rearrange it to do some substitutions and stuff. But there's an easier thing that they have in common. Something that they're already solved for. They both equal 180, right? Well, if that equals 180 and that equals 180, they must equal each other, right? So let's write that. Measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 4. And we did that by subs. SUBS. If you forget the S, I will mark it wrong, I swear to God. Remember, there's subtraction and substitution, so sub is not enough to get the job done.
SUBST.
SUBS for this one. T is the subtraction.
What if there's an S too? Substitution. Am I not being too pedantic?
A little. All right, so now we're here. Do you see how I got there?
Yeah.
All right, so now what are we going to do? Evan! Now what are we going to do? What now? We want to get 1 and 4 together. They're in the same room. What do we do, Coda?
You minus the measurement
Yeah.
from both sides.
And they go away. Isn't that magical? Not always when we minus do things go away on both sides, but because it's there and there, it will, right? So by the subtraction property of equality, we get this result. Measure of angle 1 equals measure of angle 4, which means we are nearly done with our proof. That was by subtraction. That's with the T, Danny? Mm-hmm. And then we finish it off, finish him, by writing 1 is congruent to 4, which is exactly what they wanted.
Exactly.
Swag box.
Sure, it's not what you want, Mr. Ryan.
It's not about what I want. It's about the people, what they want.
Star test. I want star test.
There's the whole thing.
Yeah.
So let's break it down. Wicka, wicka. So ABC and DBF are collinear, which means they're lines, right? And if they're lines, that means the angles upon them are linear pairs. Right? Here's the line. They're a linear pair. And if they're a linear pair, we can use linear pair theorem to get that they are supplementary. And if they're supplementary, well, we win, because that was one thing they wanted, right? But we can go further and say, if they're supplementary, that means they add up to 180, right? By definition. Same thing for this guy that we proved supplementary. Right? By the same dumb logic. Now we have these 2 guys. Notice, this guy and that guy adds up to 180. This guy and that guy adds up to 180, which means these must equal each other. So 1 and 2 should equal 2 and 4. There it is. And if you notice, I subtract the 2's, I get 1 is 4. And that's what we wanted. We also wanted to prove that 2 is 3. Now check it out. 1 and 4 we proved by saying 1 and 2 add up to 180. 2 and 4 add up to 180. Therefore, 1 plus 2 equals 2 plus 4. Cut out the middleman, we get this guy. The middleman was 2, right? Now how do I prove that 2 and 3 are related? Well, the same thing, just different angles. 1 and 2 are a linear pair, add up to 180, right? 1 and 3 are a linear pair, so they add up to 180. Therefore, 1 and 2 and 1 and 3 equal each other. What's the middleman in this one?
2.
1. 1's the middleman. See how he's in both? So we'd end up subtracting 1 from both, and we get these guys equal each other. So I'm going to save time and say, by the same dumb logic,
Oh, dang it.
by the same dumb logic,
I'm going to put that on the test.
wonderful. Angle 2 is congruent to angle 3. which we did in Pank for Cheyenne. We'll pause for station identification. So we have 1 and 4 and 2 and 3, check. And we have both the supplementary guys, check. So we're good. Yes? Zoom? Autumn, do you have glasses?
No.
Do you need glasses?
What?
It's too big, you can't read
Can
it?
you do
Haha.
the thing where you like,
Like, am I able to do that? Or do you want me to do that?
can you?
That didn't answer my question. What, Xavier? Oh, nothing? Don't even have your hand by your face. Catherine?
You're being
Don't even
too
have your hand by your face. I will call on you. I will call on you.
I'm gonna use that in every sense.
I don't listen to anything you say. Like, you know that, right? As long as we're both cool with that, yes.
I don't have a question. I just
Wonderful, thank you. All right, questions on this one?
Are those your jokes on the board?
No.
I mean, on the door?
No, but I need to put my own jokes up. There's a picture of Danny Mao, the greatest joke of all. All right. What a joke. 9 or 10? Or both? Enough! 9 or 10?
Reverse card.
let's do 10
We have a vote for 10.
and 9.
Okay. Katie. Don't even raise your hand by your face. I will call on you. All right. So, my suggestion, we're going to do 10 because they're both the same thing. There's only one difference. One is complementary, one's supplementary. I guess there's more than one difference. Complementary and supplementary, right? This guy has 3 angles, and this guy just has 4. It's going to be the same dumb crap, just with more angles down here. Autumn.
Make it bigger.
I will make it bigger. Autumn, maybe you should sit closer.
No.
And or get some glasses. I have a way to make that happen. I do. What about LASIK? You think about that? Right? You know, like sometimes you get like mugged and then you wake up in an alley and you're missing a kidney? Right? You know how that happens sometimes? Like you get mugged, you wake up in an alley and you have perfect 20/20 vision. Imagine that. Okay? I have the chloroform. All right. 10. For the greater good. All right. Given 1 and 2. Wouldn't that be great? I'm a superhero. What's your power? I knock people out and give them 20/20 vision. It doesn't sound like a good thing to do to people.
Good for me.
Seems nice. All right, angle 1. Nancy, what color would you like angle 1 to be? Blue? Light blue or dark blue? Good call. Angle 1 is dark blue. Angle 2, Xavier, what color do you want it to be?
Yellow.
Yellow, great choice. Pick another one. Orange it is. Black. That's the joke. Katie, what color do you want 3 to be? Yep, I knew it. Is green always 3 for you, Katie? Like in your mind, does 3 have to be green? Green is everything. Wow.
Green is grass. Green is
Broccoli's green.
Your grass is green. All right. All right, angle 4. Alicia, what color? Pink.
stank.
All right, cool. Fun fact. Didn't they tell us that 2 and 3 are the same? Cool, let's make them the same color. Which one do you like better, green or orange? Green it is, Katie.
Coins. Coins.
Everything is green. It's like he set it up that way.
Coins.
Cool. Right, so let's write this down. So we want to prove, or we're given that angle 1 and 2 are supplementary, so let's write that. We're not allowed to say that they equal 180 yet, but we are allowed to say that they're supplementary. Do it in color, if you can.
I don't have colors.
Are sup. We know that 3 and 4 are also sup.
What's up?
Oh. Ladies and gentlemen, Danny Mao.
I thought you don't listen to me.
What?
I thought you don't listen to me.
What? Got him. All right. So we're trying to prove that 1 and 4 are congruent. Don't lose track of your goals, kids. All right. So given that information, can't we draw some more out of that? Right? If they say they're supplementary, doesn't that mean something?
Means they add 20.
It means they add 180. Let's write it down. So measure of angle 1.
Listen to me.
plus measure of angle 2 sums to 180. And we also know that 3 and 4 must sum to 180. And we know that both by definition, right? A little extra curl there in my def. Looks like duff. All right, so 1 and 2 add up to 180, 3 and 4 add up to 180. We have that information. Now, our goal is to get 1 and 4 in the same equation, right? That's what it says here. Well, we have 1 in one equation and 4 in the other. So how do we get them together? What do these two equations have in common? They have two things. One, yes?
2 and 3 are equal.
2 and 3 are equal. So we could do a substitution and make that a 2. And then solve for 2 up here, right? Move the 1 over and get 2 equals 180 minus angle 1. Plug that in there. Do math. That's a lot. And sometimes you're going to have to do that. But right now, what's the easier thing that they have in common? 180. So if that equals 180 and that equals 180, then they must equal each other. Sound familiar? Right?
Yeah.
Okay, so let's do that. Angle 1, the measure of angle 1, plus the measure of angle 2 is going to equal the measure of angle 3 plus the measure of angle 4. We did that by substitution. Let me show you why that's subs, just in case you don't see it. SUBS. 1 and 2 equals 180. But we know that 180 is 3 and 4. So we can switch them out. Right?
Yeah.
Are we seeing that? Because that's like the hardest part. Good. Thank God. All right. If you don't, that's okay. Seeing it is hard. Remember, it's not that you don't know what triangles are. It's not that you know how to count, right? There's 5 triangles. You just didn't see it yet. Remember that? Okay? If you don't see it, that's okay. Come see me and I'll help you out. All right. So now we're here. Now we got 1 and 4 in the same room, but they're not equal to each other. So does the math work where we can prove that they're equal? Yes. Notice color coding. 2 and 3 are the same dumb thing. Now imagine someone doesn't know the difference between this guy, or doesn't see color green, right? Well, they wouldn't know they're the same unless they know this, right? So we need to switch one of these out. That way it's obvious to everyone that it actually does, when we subtract it, go away. So which one are we going to switch out? 2 or 3? Switch out 3. All right, so measure of angle 1 plus measure of angle 2 should equal the measure of angle 2 plus the measure of angle 4. Again, these guys are both green, so they're interchangeable. It says so here, right? So I'm going to keep the 2 by request and make this a 2. And now notice when I subtract those, which is the next step I'm going to do, they're going to go away and we get what we want, right? So that was by substitution again, SUBS. We switched them out, right? We switched out 3 for 2. And now we do subtraction property and we get measure of angle 1 equals the measure of angle 4. Which means we are nearly finished by, this was subtraction property, get here, SUBT, subt. And last thing we do is we write angle 1, therefore must be congruent to angle 4. We get that for free. I know. Swag box. Swag cube. So check it out. You make a cube by putting 2 squares overlapping, right? So what happens if you put 3 cubes overlapping and connect them all up? Think about it. Think about it. All right, number 9, same dumb crap except they're complementary. Same dumb crap except they're complementary. We'll come back to it if we have time. Now, notice all of these are from your homework. This is like the 3rd time you've seen this, and we did them all in class, right? And you can watch all the videos. Did I change some of the letters and numbers up? Oh, yeah. Yes, I did. Okay? But it's the same dumb crap. Make sure you understand the concepts. How do we feel about the concept here? Supplementary, 180. If they both equal 180, they equal each other. If they equal each other, right, they should have something in common. Oh, and they do. There it is. Go away. No yawning in math class. Katie! Did we go red? Oh, we did. All right, cool. 7 or 8?
Let's go with 8.
9.
The Ocho. Any others? Votes for 7? Nah? You feel good about 7? 7 just freaks me out. I don't know why. It's weird looking. Number 8, the Ocho. It tells us that XY is congruent to YZ. So let's pick some colors here. XY, let's make them both pink because they're both congruent. So XY and YZ. Yay! Next color choice. I'm going to go with this color. Shout out to the comment section. What color is this? Is it chartreuse? Is it burgundy?
Maroon.
Maroon? You're a maroon. What? What?
You're a moron.
What? Zed will know. Oh, yeah. Shout out to Zed. Hi, Zed. He's probably watching from home. Okay? Get your tonsil taken out, kid. No more excuses. How about, yeah, we'll use maroon. It'll be just confusing enough for the viewers at home. Looks so similar to pink, right?
Can't see.
There you go. No, it just looks like black. All right. So XV and VU are the same. Cool. We'll lighten up the contrast here. We know XY and VU. Well, we already have a label for XY, right? Isn't it pink? And then VU we've already labeled as maroon. So, we have a connection here. Do you see this visually, right? We have pink and pink, maroon and maroon, and there's the bridge between them, right? That's where the magic's going to happen. Prove that YZ is congruent to XV. Now, check it out. YZ, is it a pink or a maroon? A chartreuse. A burgundy. A pinot. It's pink. XV is the other color, whatever that is. Leave a comment. All right. So, let's write what we're given, right? That's step one. I swear to God, if you don't write that tomorrow, I'll get the free points. Given XY in color is congruent to YZ. XV is congruent to VU. And then the bridge, XY, is congruent to VU. Remember, we're trying to prove that YZ and XV are the same dumb crap. Again, we want to get them in the same room, right? The same equation. So notice we have a pink and a maroon here. So right now, we've got pink and pink, maroon and maroon. We've got this thing here. We've got a couple ways we can do this, right? We can either take one of these guys and switch out the pink for a maroon, right? Or we can take this guy, switch out one of the maroons for a pink. Or we can take this guy, keep the colors, but just exchange the letters. Last time we did one of these guys, right? We moved around. How about we start from here? Right? Let's start from there. So given XY congruent to VU. Okay. So the colors are right, but the letters are wrong. So we need to switch them out. How can we switch out XY for something that'll be closer to what we want? Do you see it? Yeah, Xavier, go.
XY is congruent to YZ.
Oh, yeah. XY is congruent to YZ. So wherever I see XY, I can write YZ, right?
Yes.
So I'll do that. So this was given. And this is by substitution because we switched it out, right? SUBS. Good Lord, Autumn. We can't do this. All right. GoFundMe for Autumn's glasses. Or the LASIK eye surgery that I'll be giving her.
You'll be getting.
That's right. Optometrist. My new hobby. All right.
No.
All right, well, luckily, YZ is where we want it. So we're not going to mess with that anymore, right? We have a winning combination there. We just need to switch this guy out. How can we make VU look like XV? Well, they're congruent, so switch them out, right? We're done. So YZ, therefore, is congruent to XV. Yeah, you're praying for this one to be on there, right? And that's by subs.
It's not gonna be right. It's too easy.
We'll see. Swag box.
Still doesn't make it. Swag cute.
Nah, too easy.
Make it a
But
right
empty.
angle.
I don't do requests.
Wow. Wait, we didn't hear something like that.
No, we didn't because it's Thursday. Dummy.
It's
Alright.
not.
So we don't do it on Fridays.
Yeah. any day that we have a quiz or a quiz review.
Dang.
Try to give you as much time as possible. How you feel?
I feel great.
All right, lost? You stop
I
that.
did 9.
All right, you want to see 1 or 2?
Could we do both?
No, 1 and 2 are easy.
Remember multiplication property of equality, subtraction property of equality, all that stuff. You're just going to need to justify your algebra, right? 3 and 4, how do we know that they all add up to the big thing? What's the theorem that allows us to say that?
Transitive.
No.
A from B, B to C.
That's equal signs. I'm saying they all add up to the big thing. So AB and BC should add up to AC. How do we know that? Yeah, go ahead. Segment addition, right? Segment AB, segment BC add up to the big segment, right? If you draw it out, ABC collinear, well, there's ABC collinear, right? AB plus BC should be AC. That's by segment addition postulate, so make sure you know that. And then after that, it's all algebra, right? Set it up, knock it down. You would write AB plus BC equals AC by segment addition postulate, SAP. And then after that, we'd plug in their values, right, by substitution. You dig? Got to have those first 2 steps. Can't just go straight to the algebra. Same thing for number 4. Mucho cuidado, por favor, with the negative signs. Okay. Okay. So let's go back. Get rid of these guys. Would you like to see 1 of 1 or 2? Would you? Would you like to see number 2?
Yes.
Before we go back? Okay, we'll do number 2. All right, so number 2, it says given this crap, prove x is negative 32. Okay, cool. So all we have to do is write out what we're given, and that's this. I'm going to switch it up and put my justification on the left just to screw with you. All right, so now we're here. PEMDAS is lie. Do anything you want. We can add 3. We can multiply by 2. What do you want to do first? You want to multiply by 2 first just to get crazy?
No.
You want to get crazy? Let's get crazy, okay? Right in the face of PEMDAS. Suck it, middle school math teachers. All right, so here we go. We're going to multiply by 2 to both sides, and we get this. Now, remember, when you multiply by 2, just like division, multiplication gets everywhere. It's kind of messy, right? So this is going to be, what, negative 38? I think of that as negative 20 doubled, right? But it's 1 less than that twice, so it's 38. So I did that by multiplication property, right? So again, when you go outside of PEMDAS, you just have to be careful. Everything gets multiplied by 2, every term, right? And we had 1, 2, 3 terms. Everybody cool with that? Kosher? All right, now we're going to do addition property of equality, which is what we would have done anyway, right? And we're going to get x equals, what's negative 38 plus positive 6? Catherine. Wow. It's like she knew it already. Crazy.
Swag.
Katie, I would never say this out loud, but I enjoy having you in class. All right.
Wow.
Swag box.
Can't say that wrong. You just did.
That's the joke. That's the joke. One of these days, like 1 year, we're going to have an entire year that goes through where I don't have to yell, that's the joke at somebody. All right.
We'll make it more fun.
That's not what I said, but I do stand by that statement.
I'm saying.
5 and 6. Which one?
6.
5 should look really familiar to the homework. 6 isn't. It's just different letters. So given Q is in the interior of XYZ, well, here's XYZ. I'm going to draw it as an obtuse angle just because I'm feeling very obtuse today. Oh, look, it is obtuse. It's 100. Yay! Doesn't have to be drawn to scale. It could have been a cube and we could have drawn it like this. Doesn't matter.
Kid in the candy store, Mr. Ryan.
I don't know what that means. All right, Q.
Sounded like.
Q is in the interior. Now you're probably wondering, how do we know that's the interior and this isn't the interior? I don't know. I think we just always assume that it's the smaller angle that's the interior. I don't know. I've never really thought about it that much. Angle XYZ is 100. Hundo. So let's make that blue, dark blue. That's hundo. XYQ. Let's make that pink. XYQ is this angle. That's x plus 57. And then we know that ZYQ is negative 5x minus 5. So that's this angle. I really think the colors help here. So we need to prove that ZYQ is the green, right? That is 55, Shrifty 5, okay? So now what? We need to get some equations going on here. Right now we just have expressions, right? That's negative 5x minus 5. That's x plus 57. That's 100. We need some equal signs here to set them up and get them in the same room because that's what we need, right?
X plus 57 minus.
Now here's the deal. We can't just start setting things equal number-wise. We have to first establish why we're allowed to do that. Now you're going to tell me that the pink plus the green adds up to the blue, right? So how do we write that? Katie? Angle addition postulate, which says the pink angle XYQ, plus angle ZYQ should equal the blue angle, the big one, right? Angle XYZ. Try to make sure you keep the letters in the same order as they do, right? Because they want it ZYQ, not QYZ, right? Both would be valid. ZYQ is the same angle as QYZ, but it's nicer if you write it their way. All right, so we know that by angle addition postulate. Very good, Katie. Someone is catching on. Everybody forgets angle addition postulate and segment addition postulate. I don't know why, but they do. So don't forget it, okay? Know that you're going to, so make sure you don't. So here we are. Therefore, the measure of these angles, which I should write here, right, all adds up to the measure of this guy. We can do substitution now. Instead of XYQ, what's the measure of XYQ that they give us? X plus 57. I'm writing in parentheses just in case, you know? Just in case. ZYQ, let's do that in green, by the way. ZYQ, what do they give us for that value? Negative 5x minus 5. And then the blue one they give us is hundo. Right? Parentheses are more for organization than anything. Right? Just showing you what was switched out. And again, if we switched it out, we call it by substitution, SUBS, I swear to God. All right, now it's just all addition and subtraction, right? We get stuff together. So we use a giant therefore sign because we don't need to justify this. X and negative 5x, that's going to be negative 4x. And 57 minus 5 is 52. Okay? They're all on the same side. We didn't move anything, right? So that's just putting stuff together. It's basic arithmetic / algebra. All right, now we need to get this moved over. So that's going to be a subtraction property of equality, right? When we move that over, we're subtracting 52. So what's 100 minus 50? 50. Now subtract 2 more. 48. Again, make it easy on yourself. That was by the subtraction property, SUBT. And then last but not least, we're going to divide, right? So x is going to be 48 divided by negative 4. Well, it's going to be a negative answer, right? Put that down so I don't forget about it. What's 48 divided by 4? 12. So x is negative 12 degrees. Yeah. By division. So the question is, are we wrong? Can we have negative degrees?
Yes.
Well, let's check it out. If we plug it in, do they add up to 100? Negative 12 plus 57, what's that? 45. So this would be 45. Then we're supposed to add it to this guy. What's negative 12 times a negative 5? It's going to be a positive answer. 60. Add or subtract 5 from that. Shrifty 5. Girlfriend's age, Shrifty 5. So yeah, it does make sense. 45 and 55 does add up to 100. So x is negative 12 degrees. Right? Doesn't have to be degrees. Doesn't have to. Does not have to. Also, you can't have negative degrees, but it's beyond the point. Are we done?
No, sir.
We're not. We're not, right? What do they want us to do?
Plug it in.
Yeah, they want to know what ZYQ was, right? They said ZYQ is 55. We got to prove that. So we're not done. Just kidding. Guaranteed that'll happen to you tomorrow. Don't let it be you.
Probably same dumb marker.
Okay? No. What we're going to do is we're going to say, given that ZYQ, they didn't give us that it's 55. Remember, we're proving that it's 55. They gave us this. They did not give us this. That's proving, right? They gave us this. So given that ZYQ is negative 5x minus 5, I'm going to do that over here. Given measure of angle ZYQ is negative 5x minus 5, I can do substitution and get this. What am I plugging in for x? Negative 12, right? That's by subs. And now I do negative 12 times negative 5, which we did earlier, was 60, minus 5, which is 55. So therefore, measure of angle ZYQ is 55 degrees. Flag box. For real this time. I'm squeezing this all in. I like them apples. Dees?
I really don't like apples.
Yeah, apples actually are pretty overrated. Although, it's just that most apples that are in the store suck. Like Red Delicious. Lies! First of all, it's not red. It's more like chartreuse, burgundy, maroon. You're a maroon. Second of all, not delicious. Disgusting. You ever bitten into a Red Delicious and been like, mmm, delicious? No, they're all gross. They're all gross. They're so mushy, too. All right. That's that on that. Number 5 is the same dumb crap. Again, when you plug stuff in, I would encourage you to wrap it in parentheses just to be safe. It'll save you a lot of little mistakes that I have to fix later, right? Right? Parents know what I'm talking about. All right. So, any other questions?
Just the way we like it.
All right.
9 was pretty.
9 was pretty easy. I think 9 is easier than 10. Yeah.
All you had to do is just.
Here's my advice. Here's my advice. I'm not saying the quiz tomorrow is going to be easy because, like, good Lord, it's one of my quizzes, right? There is no such thing as an easy quiz from me. And this is new. And you've never really done proofs before now, right? But my advice is, for this one, this is very doable. If you put in the effort, you will see the results, okay? Put in the effort. Knock this one out of the park as best you can. It's not easy, but it's going to be easier than the next one. So take advantage now. If you're lost, where were you the last week and a half? You should have been seeing me, okay? Come in now. I'm not going to be here much today. Thursdays I have to drive to Cal. But come in after school. We'll try to squeeze you in, okay? Or come in during homework. If you haven't fixed your quizzes or tests already from the first 3 that we had, what is wrong with you? What are you waiting for? Okay? Get in here. Testimonials. If you've been in here, okay? Raise your hand. If you've been to see me and gotten help at all this year yet, raise your hand. All right, look at all these people. Would everyone that's here agree that when you came in, all of a sudden, bam, everything just made sense? Except for you. I tortured your mind. You deserve it, okay? In like 20 minutes, I can explain 3 weeks worth of material. It's amazing how much you can figure out, okay? You are not beyond hope. So all the people that raise their hands, all morons, right? All dumber than you, but they did fine, right? So you'll be great. You'll be great, right? Danny raised his hand. We all know we're better than him. Look at him. Just look at him. Offensive. All right. We have time left? How do we have time left? We did more problems than the last class. 39 when we're getting out of here? All right. Everyone go away right now.
Serious? I'll
Don't
leave.
wait. Seize the day.
I don't want to go away.
You have to.